Yeah?
Yeah?
Let's see what kind of shot you get.
Yeah.
Do you need it in like more like in an angle? Or is this okay?
I think it's okay because I will have the movement, no? Or,
Yeah.
or do you think maybe from further? I don't know.
Because what if there's something really exciting going to happen here? So maybe over there,
Yeah?
because then you have more floor that you can cover.
Right.
I want to ask you to think about your favorite music artist for a moment. Got someone in mind? Now imagine that this artist is coming to the Netherlands, and you're determined to be there. With a bit of luck, you manage to score a ticket, and after months of waiting, the night finally arrives. You walk into the concert hall, only to find out you can't actually see the artist, and you've been separated from your friends because you're placed all the way in the back behind the light and sound booth. Sounds unacceptable, right? Unfortunately, this is the reality for many people who are permanently wheelchair-bound and want to attend a concert. An experience that should be fun and relaxing often turns into a frustrating and nearly impossible challenge. And the problems start long before the show begins. Even booking a ticket can be difficult. Take the Ziggo Dome as an example. It holds 17,000 people, yet only 20 seats are reserved for wheelchair users. If you do manage to get a ticket, there's still no guarantee you'll actually be able to reach your seat. Many concert venues claim to be wheelchair accessible, but in reality, they often only accommodate people who can still walk a few steps. For example, so-called accessible seats may still require climbing a small staircase or navigating narrow pathways. This means that people who are permanently wheelchair-bound, that rely entirely on their wheelchair for mobility, are often left out. And if all that works out, the experience can still be disappointing. Many wheelchair spots are poorly located, in the back of the hall with a blocked view, or right next to the speakers on the side, meaning you might have to leave the venue with ringing ears after just 1 hour. A large part of the people who are permanently wheelchair-bound are people with a complete paraplegia. This is a medical condition caused by damage to the spinal cord. Worldwide, in the Netherlands, about 15,000 people have a spinal cord injury. Worldwide, this number adds up to 15 million people. Below the level of injury, there's no motor or sensory function, which is why people with paraplegia rely on a wheelchair. Relying fully on a wheelchair doesn't just cause mobility issues. It also affects physical and mental health. Being permanently wheelchair-bound leads to muscle decay and a loss in bone density. The cardiovascular function deteriorates due to reduced blood flow in the paralyzed limbs, and bladder and bowel control are often impaired. On top of that, there's a psychological toll as well. Having to accept that your body does not work in the way that it did before, and being unable to maintain eye-level contact with the people around you. At Project March, we try to make a difference. My name is Maaike Braquet, and I'm this year's team manager of Project March. Each year, a team made up entirely of students builds an exoskeleton to improve the quality of life of people with paraplegia. An exoskeleton, or EXO for short, is a robotic suit that enables people with paraplegia to stand up and walk again. This helps mitigate a lot of the negative physical effects of sitting in a wheelchair. By standing up and applying force to the bones, bone density improves. Additionally, moving the paralyzed limbs enhances blood flow, which positively impacts cardiovascular health as well as bladder and bowel function. But not only does physical health improve. By standing up straight, the pilot is once again able to communicate on eye level with others. It all started in 2015, when Project March was founded. The very first team of Project March not only developed an exoskeleton, but also laid the foundation for the upcoming teams. In the first 5 years of Project March, the focus was on the Cybathlon, also known as the Bionic Olympics. The Cybathlon takes place every 4 years and features several disciplines in assistive technologies, including exoskeletons. March 1 through 5 all worked towards competing in this event. From March 6 onwards, the focus broadened. While the Cybathlon remained an important milestone, the teams began exploring broader applications, enabling the user to walk outdoors on uneven terrain, improving the exoskeleton's balance, and making it more suitable for daily life. And now, it's 2025, the year of Project March 10. Just like the teams before us, we had to decide, what will be the focus of our year? It didn't take long before we all agreed. We wanted to focus on the societal impact an exoskeleton can have. To shape that vision, we sat down with the person who wears the exoskeleton built by our team, our pilot, Daan van der Heijden. Daan has had a complete paraplegia from below his chest since 2017. He helped us understand which situations are particularly challenging when moving through the world in a wheelchair. He told us that crowded public spaces and social events are often difficult to navigate. So, we decided to build an exoskeleton that can help people with paraplegia better participate in those moments. And what better way to represent social events than through concerts, something almost everyone knows and enjoys. That's why tonight, Project March 10 is here to show you that standing at a concert is no longer out of reach for people with paraplegia. We would have loved to show you our pilot in action with our exoskeleton, but unfortunately, due to medical reasons, he will not be walking in our exo tonight. However, we will show you our exo in a live demonstration. Making that possible in just 1 year takes an incredible team. And so, it is my honor to introduce them to you now. This is Project March 10.
Wat is nu voor energie?
Mijn eerste indruk van het team was super gepassioneerde en gemotiveerde mensen. Die wel allemaal totaal verschillend waren, maar wel met één doel aan dit jaar begonnen.
Dat het zo'n hechte groep is geworden, ja, dat vind ik wel heel leuk om te zien.
Ik heb leren samenwerken met studenten van verschillende studieachtergronden.
Heel veel C++ programmeren.
Hoe met hardware te werken, omdat we doen dat nooit bij de universiteit.
Überhaupt hoe zo'n groot project werkt.
Vooral mijn CAD-modelleerskills wel goed ontwikkeld dit jaar.
PCB-design. Maar ik denk vooral problemen oplossen.
Ik heb ook veel over mezelf geleerd, waar mijn grenzen liggen.
Fouten die je hebt gemaakt zijn alleen maar goed dat die fouten er zijn geweest. Omdat je ervan hebt geleerd.
De grootste fout? Nou, we hebben nog wel wat dingetjes opgeblazen.
Ik heb een blade connector gesloopt en wellicht dat door het design van mijn backpack daar een hele backpack uit elkaar moest.
Niet om hulp durven te vragen aan anderen.
Nou, gelukkig heb ik niet grote financiële blunders gemaakt, dus dat scheelt.
Ik heb alles perfect gedaan.
Ik weet wel nog dat ik echt heel trots was op mijn allereerste ge-CNC'de onderdeel.
Ik moest een video maken en ik had eigenlijk nog nooit met dat programma gewerkt. En ik ben best wel tevreden geweest met hoe het er uiteindelijk uit is gekomen. En ik ben best wel een perfectionist, dus ik had dat niet helemaal verwacht.
Ik ben trots op dat we in redelijk weinig tijd heel veel hebben kunnen doen met software. En ook heel veel hebben kunnen innoveren.
Ik denk dat ik heel veel heb gedaan wat ik nog nooit eerder heb gedaan. En dat het eigenlijk best goed ging. Ik ben gewoon trots dat iedereen het zo goed doet, volhoudt en gemotiveerd blijft.
Alle mooie evenementen die we hebben bij mogen wonen, waarbij we mensen wat meer kunnen bijbrengen over hun dwarslezing en exoskeletten.
Het hele exo, dit heb ik samen met mijn team gedaan. Dat vind ik wel echt heel gaaf.
Mijn favoriete onderdeel van het exo zijn de M-drives, omdat we die met z'n allen in elkaar hebben gezet.
Mijn favoriete onderdeel van het exo zijn de covers.
De voet natuurlijk, met de kop wat linears.
De endstop.
De backpack.
De Babs heeft wel een speciaal plekje in mijn hart.
Het input device.
Ja, de software natuurlijk.
De stedenestimator.
NPC. De GPU.
Fixtures. Uiteraard. Ik denk dat ik iets van 25 onderdelen heb gemaakt.
6 en 8 en 2, ja, volgens mij 16.
Ja, ik denk wel echt dat ik honderden uren geblenderd heb.
Ik denk dat er dit jaar rond de 42 evenementen zijn geweest.
Meer dan 100 3D-printjes.
Hoeveel mails ik dit jaar heb gestuurd? Ik denk 1500.
Ik denk dat ik dit jaar zeker richting de 10.000 regels aan code heb geschreven.
We hebben ook wel heel veel regelscode weggehaald dit jaar.
Hoe vaak denk je dat ik een error voorbij heb zien komen? Ik denk echt...
Oei, te veel.
Ik denk dat we wel 150 gates hebben gemaakt aan het eind van dit jaar.
Als ik één moment van dit jaar opnieuw zou mogen beleven, dan zou dat het moment zijn dat we met z'n allen op het podium stonden aan het eind van de design presentation.
Vele Mars-uitjes die we met het team hebben meegemaakt, die zou ik graag gewoon nog een keer willen doen. Met z'n allen naar de Efteling.
Het aansluiten van de M-drive en helemaal niks zien gebeuren. En dan één kleine oplossing en dan een lampje zien branden.
De assembly van het EXO.
Als mechanical engineer is het natuurlijk wel mooi het eerste keer het EXO helemaal in elkaar te zetten.
Als de dozen openden met onze allereerste zelfgemaakte PCB's. Het is gewoon een soort nieuw Sinterklaasdagje weer.
Dat we met het hele team in het begin naar de Cyberton zijn gegaan.
De eerste keer met Daan in onze EXO lopen, ook al waren het 3 kleine stapjes, was dat toch wel echt heel mooi om te zien.
Ik denk dat ik dit jaar afsluit sowieso met een heel goed gevoel. Ongeacht van hoe de reveal gaat, ongeacht van hoe het EXO straks gaat lopen.
Maar als de reveal goed gaat, dan is het natuurlijk nog een stapje leuker.
Met een ontzettend blij, positief gevoel. Dat ik blij ben dat ik deel heb mogen uitmaken van dit team.
Ik ben gewoon heel blij hoe we dit Exoskeleton als team hebben neergezet en hoe hard we hebben gewerkt tot aan het einde.
We zijn al zover gekomen met dingen die nog nooit eerder zijn gelukt.
Ik denk dat ik er heel lang goed op terug ga kijken.
We hebben heel veel mooie herinneringen gemaakt.
Ik sluit het jaar wel een beetje met een lachende en een houdende oog af.
Ik denk dat ik het jaar wel echt ga afsluiten met heimwee naar het afgelopen jaar. Maar ook met heel veel trots.
Dankbaarheid valt goed samen. Ja.
Almost a year ago, in August 2024, this group of students started on a challenging mission. They put their studies on hold to fully commit to a year of Project March. With various study backgrounds, they came together to form a diverse team. And while, at first, many were strangers to each other and unsure where to start, all of us were brought together by one shared ambition: to build an exoskeleton for people with paraplegia. Something bigger than any of us could achieve alone. And with that goal in mind, our journey began. So we kicked off our year with a handover from the previous team. But by the end of the week, it was up to us, the 10th team of Project March. But how did we get from that very first week to tonight? The reveal, where you will see our exoskeleton in action. My name is Cindy Hay, Project Manager of Project March 10, and I will guide you through the steps that brought us here tonight. We look back on the things that we've done along the way, the milestones we've reached, the challenges we faced, and the progress we made. So a year at Project March can be broken down into 5 distinct phases, each with its own focus. We started off with the analysis phase, continued with the conceptualization, detailed design, and production, and ended with the testing and training phase. So it all starts with the analysis phase, a period in which we try to understand all the working mechanisms of the exoskeleton. We also looked at exoskeletons from previous March years and research groups to see what they had already achieved and where there was need for innovation. And with these insights, we defined our innovations for this year and set our ultimate team goal. Project March 10 will build an exoskeleton that enables the pilot to attend a standing concert by standing self-balanced while resisting external disturbances, and by walking more naturally to decrease the physical effort by the end of July 2025. And in this team goal, there are three main components that shaped our work. First of all, our exoskeleton allows the pilot to stand self-balanced, meaning standing upright without the support of crutches. Second, it maintains this balance even when facing external disturbances, like a push from the crowd in a standing concert setting. And finally, walking in the exoskeleton requires a lot of body strength, as the pilot relies heavily on his crutches to walk. By optimizing the walk, we aim to reduce the physical effort for the pilot and make the use of the exoskeleton less demanding over time. And with this team goal set, we ended the analysis phase and rolled into the conceptualization. So now, it was time to set some concrete steps on how to realize that team goal. And this phase consisted of extensive brainstorming to form ideas based on all the research we had done so far. And together with a lot of sketching, simulations, and modeling, many prototypes were created. These prototypes then went through multiple iterations and were refined into the final versions that were locked in for the rest of the year. And in this phase, we also got a lot of help from our partners, who supported us in our designs and ensured the best components for our exoskeleton. And all these key decisions came together in the detailed design phase, where each department contributed to our common team goal. So the mechanical department worked out designs of all the frame parts and redesigned the rotational joint. And they also developed a new active ankle joint that would be best for walking and standing balanced. The design engineers combined colors, shape, and function to create many designs for the covers and evaluated those with the team. The electrical department decided to completely redesign the motor controllers, and they introduced 2 new sensors and a new type of battery. And finally, the software engineers restructured the code base of 10 years Project March and found ways for our exoskeleton to stand balanced. And with both the new software and our pilot's guidance, we were able to run our very first tests on an older March exoskeleton, which gave us useful insights on how we should proceed. And then, by the end of this phase, all our ideas were visualized and presented to the outside world during our design presentation, which attracted a record number of more than 760 guests, which made that day even more special than it already was. And then it was time to bring all our ideas to life, and the first features of the exoskeleton began to show. The mechanical engineers learned lathing and milling and spent hours behind the CNC machines, where they made many parts of the exoskeleton themselves. The design engineers were often to be seen behind the 3D printers. And the electrical engineers even managed to acquire their own assembly machine to assemble their own circuit boards in-house. And so, bit by bit, our exoskeleton started to take shape, from sketches and computer models to something physical. And eventually, in April, all components to build the EXO were finished, and we were ready to assemble our own exoskeleton. And this was a moment we had been looking forward to after months of hard work. So we celebrated this milestone with a well-deserved bottle of champagne. But after celebrating this milestone, there wasn't much time to rest. Because next up, we had to prepare everything to start our testing phase. However, after the assembly of the exoskeleton, it just hung there in its stand, not knowing that it would be motionless for still a few more weeks, since crucial components didn't seem to work. One of the biggest setbacks we had this year was that we couldn't seem to get our exoskeleton moving. And that shows that a year at Project March isn't just about achievements and celebrations, but with setbacks along the way. So for many hours, days and weeks, our engineers poured their time into identifying the root causes of the faults, determined to get the exoskeleton back on track as soon as possible. Team members jumped in to help with the challenging code of the motor controllers, while others focused on assembling many more circuit boards. And some even baked cookies for the team to keep everyone's spirits up. It was a demanding period of hard work and dedication, a lot of uncertainty and constant problem solving that kept us on our toes. But then, finally in June, Daan took his first steps in our own March exoskeleton, an important milestone that marks the start of the training phase and showed off the hard work of our team. In the training phase, we fine-tuned the software of the exoskeleton by controlling it both in the air and on the ground. And we also tested together with our pilot Daan, who got more comfortable in the exoskeleton and walked for longer distances with each training. And together, we trained to find the optimal walk and to achieve a self-balanced stand. And that brings us here tonight, where we will show you our exoskeleton in action. So looking back at this year, we manufactured over 250 parts of the exoskeleton ourselves. We participated in more than 40 events and dedicated many hours to testing and training. And we even ended up on the radio. And some TV programs have captured our first trainings with Daan. And now we are here, on the reveal of Project March 10. A day and an exoskeleton that wouldn't have been possible without the help of our March community and our network of partners. So to wrap things up, I would like to introduce you to some partners of Project March. Those who provided us funding, parts to build the exoskeleton, or consultancy, and helped making our dreams a reality. So now, let's hear from our partners what drives their support and how they experience the journey of Project March 10.
Ziek zijn is geen keuze, zeg maar. Het overkomt je of het overkomt je niet. En we vinden het belangrijk om daar een bijdrage aan te leveren.
Het zou echt fantastisch zijn wanneer een exoskelet eigenlijk net als een soort van krukken of een rollator later ook beschikbaar zou zijn voor mensen die een beperking hebben.
En we vinden innovatie belangrijk, dus daar kwamen eigenlijk zorg en techniek kwamen samen. Dus vandaar dat we dachten, nou, dit is echt een heel mooi project die bij ons past.
Nou, wat we heel erg leuk vinden van het samenwerken met studententeams is dat jullie op hele korte termijn een heel ambitieus project willen gaan oppakken.
Als ik het dus over de simulatiekant heb van het verhaal, jullie zijn vooral aan het begin van het jaar redelijk nieuw in die dingen. Het is voor velen van jullie de eerste indruk die jullie krijgen van het doen van simulatie, of het nou sterkte is of systemen. We vinden het leuk om jullie daar een beetje mee op weg te helpen.
Ik probeer ook richting te geven aan de methode van testen. Want dat leer je niet automatisch op de universiteit.
Op het moment dat je echt iets moet gaan bouwen, dan zie je dat de praktijk soms weerbarstiger is.
Dat is wat ik de studenten ook probeer mee te geven. Doe het in kleine stukjes en dan komt het grote resultaat.
Mijn zus zit in een rolstoel, dus ik weet zelf wel welke uitdagingen je meemaakt als je zelf niet kunt lopen.
De enorme verschillen in dwarsleesiepatiënten. En dat dan ook echt niks met de persoon te maken heeft, maar dan echt met de hoogte en hoe iemand dan dus lichamelijk kan functioneren.
En worden wij erbij geroepen als fysiotherapeuten om mee te denken over haalbaarheid en nut en de mogelijke problemen en oplossingen bij die ontwikkeling.
En dat het absoluut geen one-size-fits-all oplossing is, wat toch wel lastig is bij zo'n complex iets als een exoskelet.
Dat je toch heel veel opnieuw moet maken zodra er een nieuwe piloot is, want de situatie verandert echt compleet.
Het is heel mooi om te zien hoe jullie aan het einde van het jaar dan zo'n heel nieuw exoskelet weten neer te zetten met allerlei nieuwe mogelijkheden.
Dat vind ik een heel mooi concept. Het feit dat studenten hun studie een tijd lang opgeven om aan iets anders te werken.
Ik denk dat jullie van alle studententeams wel een van de nobelere doelen hebben.
Ik vind het ook heel inspirerend om te kijken hoe jonge ingenieurs zich ontwikkelen.
Maar jullie zijn gewoon zonder winstoogmerk en het doel om het beter te maken voor degene met een dwarslezing. Ik denk dat dat heel waardevol is.
Echt een dreamteam, denk ik. Ja.
The experience of attending a concert has been mentioned quite a few times now. It is clear that for wheelchair users, it can be a challenging, a tiring, and sometimes even an impossible experience. Our solution, an exoskeleton. As mentioned before, this is a robotic suit that allows wheelchair-bound people to stand up and walk again. But is standing up and walking enough? Attending a concert might seem like an overall simple task, but it contains several aspects that become very challenging when looking at them from the perspective of an exoskeleton. My name is Karel Gimberg, and I'm the lead software of Project March 10.
And my name is Tina Geluk, and I'm one of the mechanical engineers of Project March 10. We are going to take you through the experience of attending a concert. An experience most of you have had before. First, you walk through the entrance doors and have your ticket scanned. Then, you make your way towards the concert hall, moving up several steps as your anticipation for the concert builds. Finally, you reach the concert hall, one similar to this one, here in Tivoli. And it's already crowded with people. All around you, there's noise. You feel the energy is rising as you pave your way through the crowd to get to a good spot. Along the way, someone accidentally bumps into you. But you do not care, as your favorite artist is about to come on stage. The lights go down, and the concert starts. And everyone's favorite song comes on. People around you start to move. The excitement builds, and shoulders brush. But no one minds. It's part of being in such a vibrant environment. There are many points in this experience that are simple to most of us, but very challenging to an exoskeleton. We will tell you exactly how we as Project March 10 have tackled each of these challenges. But before we do, we need an exo to begin with. Let's start by building it from the ground up. Our exo is designed with 5 main components, each inspired by the human body. First, the bones of the exoskeleton, the frame. The frame provides structure, supports Dan's weight, and keeps all components aligned. Next are the muscles of the exoskeleton, the joints. These motorized parts enable the movement of the exoskeleton and are located in the hip, knee, and ankle. There are 2 types of joints, the rotational joint and the linear joint. The rotational joint creates rotational movement, like the name suggests. There are 4 in total, divided over the hips
and knees. The linear joint, on the other hand, extends or retracts to create movement. There are 2 in the hips and 4 in the ankles. Using these 10 joints, our exo is able to move in many different directions. Then there's the brain. Just like our brain controls our muscles, we have a powerful computer to control our mechanical joints. Here, the movements of the exo are determined, and all data produced by our exoskeleton is collected and processed. This powerful computer enables the exo to respond quickly, yet accurately. These responses have to be communicated with the joints. In the human body, nerves connect the brain to the muscles and sensory organs. They transfer information all throughout the body. Our exo uses sensors and cables to perform this critical function, enabling communication between the computer and the joints. Lastly, the covers and the fixtures form the skin of the exoskeleton. They provide an extra layer of protection, shielding both the pilot and the internal components. To better showcase the underlying technology and to quickly detect problems, we've added several transparent elements to the covers. To connect down to the exo, we have fixtures for his torso, upper, and lower leg. These are custom-made parts to best fit our pilot's anatomy. Together, these 5 main components create a system that mimics the human body, allowing for controlled and natural movement.
Now that we have assembled our exoskeleton, let's return to the steps of getting to the concert hall. First up, deciding where to go and how to get there. These choices have to be communicated with the exo, and this is where the input device comes in. The input device has to be able to operate under any circumstance, as a concert can be loud and crowded. Therefore, with a design similar to a game controller, the pilot is able to maneuver through the crowd without having to think about where to find which button. After pressing one of the options on the input device, such as walking, this choice is then sent to the computer. The computer then determines whether this choice is possible or not. For example, you cannot start walking without standing up first. If the choice is acceptable, it is then sent to our custom-made motor controllers. These are placed at 5 crucial points throughout the exo. Not only do they make sure that the chosen action is executed, they also send back any data that is picked up by the many sensors in our exo. So, the exo has been given a command and starts to walk. But what does a walk look like for someone? One takes slower but longer strides, while someone else might prefer to walk with frequent short steps. For our pilot, this is no different. To make this customization possible, we have developed an application that Dan can use to adjust almost anything about his walking pattern. This includes the speed at which he swings his leg, how much his ankle pushes forward, and the height at which his foot clears the ground. In collaboration with our team and the physiotherapists, the pilot has complete control over the way he walks. Not only does this give more control to the user, it significantly speeds up the process of finding an optimal walking pattern. As we comfortably walk towards the concert hall, we see a level difference coming closer. For most of us, a small step up will be no problem, and we will likely not even look down while doing it. Mindlessly, we determine exactly how far and how high we should step to not trip over. For our pilots, this process is broken down into a few steps. First, Dan looks ahead and makes sure that he stops walking well before the step up. Then, within a few small steps, the distance to the level difference can be decreased to a steppable size. Once this is achieved, our EXO uses depth cameras and custom software to determine exactly how far and how high it should step to get on top of the level difference. Based on this information, the movement to step up is generated in real time.
After you've arrived at the concert hall, your next step is finding the spot that feels just right. As you move through the crowd, you encounter people, lots of people, many of whom carry a drink, and when you walk past, you might accidentally bump into them, causing them to spill a little of their drink. Since this can pose a problem for our electrical components, we've decided to make all covers splash-proof. Therefore, several adjustments have been made. In our rotational joint, we've added a flexible material that moves seamlessly with the joint. We've also made covers for our linear joints, as well as smaller electronic components, all throughout the EXO. All these changes allow for a more carefree concert experience. Previous march teams have focused on short and high-intensity performance. But as a concert doesn't consist of simply one song, we've shifted this focus towards endurance. Therefore, we've chosen to work with a larger battery pack than previous years. We've also focused on something else: standing self-balanced. In most cases, the pilot needs to use crutches to help remain balanced, both during walking and in a standing position, which requires a lot of focus, impairing his ability to simply enjoy the moment. For this reason, we've designed an exoskeleton that's able to stand self-balanced, eliminating the need for crutches and allowing the pilot to freely move his arms. But how does the exoskeleton remain balanced?
If we want to stay balanced, it is crucial that our EXO can detect any sudden change in its pose due to a push, for example. Therefore, we have equipped our EXO with a total of 45 sensors. They tell the computer about the positions of the joints and how fast each limb, for example, the lower leg, is moving. They also tell how much force is acting on each of the joints, and they show us what is in front of the exoskeleton. All of these sensors add to a so-called digital twin on the computer. This digital twin is an exact replica of our physical exoskeleton, but in our digital world. Any changes in the physical world are directly applied to the digital twin, and our software can react to these changes accordingly. One thing our EXO has no information about is Daan's body, although it strongly affects the balance of our exoskeleton. In order to ensure optimal control, we have developed a torso fixture that closely attaches Daan to the EXO, perfectly following the shape of his back and allowing for accurate stabilization of his torso. One other thing that we can use to stay balanced is weight distribution. As a child, we learn through trial and error that the best way to stay balanced is to keep our weight above our feet. Our EXO measures this using pressure soles. These are sensors underneath the feet that tell exactly how its weight is distributed on the ground. From this, we can derive whether it's leaning to the side or forward, whether it's standing on both feet or just one. But what happens when our EXO does receive a push? How does it know what to do? It can now detect any change in its positioning and weight distribution using all of its sensors, but giving the correct response to stay balanced is not at all straightforward. To make this decision, we use an algorithm called model predictive control. Here, the word predictive gives away the most about the workings of the algorithm. At every moment in time, we make several predictions using our digital twin from earlier. What will happen when we rotate our right knee? And what will happen when we tilt our ankle a little inwards? Our exo constantly plays out many of these possible actions on the digital twin. Then, based on a set of criteria, it chooses the action that results in the best balance and performs this action on the physical exoskeleton. In order to find an action that balances well, our exo must try a very large amount of possibilities. For this reason, we have equipped our exo with a very powerful computer that can run a huge number of these actions simultaneously. When one of these actions is chosen, it also needs to be carried out right away. But there's one tricky aspect when trying to carry out these movements. Mechanical joints have static friction, a sort of stiffness that hinders their initial motion. To prevent any delay in our movements, we use a control method that measures the amount of force that is needed to overcome this friction. You could see this as equipping our exo with quick reflexes, allowing for instantaneous and smooth responses.
After all these predictions, let's go back to the present, having the right tools to respond to a disturbance. To react to such a challenge, the human body mostly uses its ankles. Therefore, we've redesigned the ankle joints. With our improvements, we are able to actively control the side-to-side movement of the ankle on top of the up and down motion. This allows our exoskeleton to remain standing without the need for extra support, like crutches, even when it is pushed. This is done using two linear joints that work together in a coordinated way, placed on the side of the foot. They allow for two types of movements. If one linear extends and the other one retracts, the foot is able to move up and down. When both linears extend or retract at the same time, the ankle is able to tilt sideways. This may seem simple, but to be able to move the foot, our software needs to steer these two joints at exactly the same time, with exactly the right speed and force. A level of control that's never been achieved in a Project Mars exoskeleton before. Using model predictive control and the active ankle joint, our exoskeleton is able to withstand pushes for both the back and the side, allowing Dan to simply enjoy the concert.
This makes our concert experience complete. Using our exo, the pilot can comfortably walk into a concert hall, overcome a level difference, safely maneuver through a crowd, and stand self-balanced during a concert. Using our innovations, we are one step closer to making a concert an accessible experience for all.
We've just taken you through all the innovations of our exoskeleton. The technology, the control systems, the balance, the mechanics. But now we want to talk to you about why we built it. Not just the how, but the purpose behind it. Because at its core, this project isn't just about walking. We really want people with paraplegia to be able to participate. A concert is a place where people meet. A perfect example of a social event that brings people together. We chose a concert for a reason. Not because it's ordinary, but because going to one should be. My name is Kirsten Meekes, and I'm proud to say that I'm this year's Operations Manager of Project March. So yes, we chose a concert to showcase our innovations. However, our goal reaches far beyond just one event. This concert stands for something much bigger. It's a symbol for freedom of movement, social accessibility, and spontaneity. Because being able to move freely isn't just about taking steps. It's about making decisions without obstacles. The Dutch law defines accessibility as follows. The condition in which buildings, facilities, products and services are designed so that people with disabilities can enter, navigate and use them independently and on equal terms, just like everyone else. But to this day, going out often means something completely different for someone in a wheelchair than it does for most of us. It starts with planning. Which entrance can I use? Will there be a working elevator? Is the toilet accessible? Will the information online match reality? And even after all that preparation, you're often left waiting. Because the staff didn't get the memo, because the accessible route is blocked, or because the key to the elevator is missing. Even the simplest decisions, like saying yes to a friend's invitation or a last-minute event, suddenly requires extra time, energy, and honestly, a bit of luck. And that's not what freedom looks like. This gap between intention and reality becomes even clearer when we look at the numbers. On average, only 0.15% of seats in Dutch music venues are available for wheelchair users. Compare that to the 1.5% of the Dutch population that relies on a wheelchair. That's a 10-fold difference. You would think obtaining a ticket would be your biggest hurdle. But as Maika has mentioned to you before, it probably won't be your last. Even the so-called accessible seats are often a few steps up or down. And in some smaller venues, there won't be a seat at all, even though the Dutch law does require you to. And if you do manage to get to your seat, these placements are often either all the way in the back, behind light and sound, or right next to the speakers, making for a disappointing and unequal experience. And this reflects a broader issue: how we include people with disabilities in our everyday life. In 2016, the Netherlands signed the UN Convention on the Rights of Persons with Disabilities. And in 2019, we also signed the European Accessibility Act, setting basic requirements for public spaces, including event venues. So signing laws is something we do eagerly, but applying them is often left to individual organizations. There's no national enforcement. And that's where the problem often begins. Because in principle, everyone supports accessibility. Most people and most organizations agree on its importance. However, when it comes with a price tag, that support quickly fades. Once budgets are discussed, accessibility moves down the list. It's no longer seen as essential, just something extra, something for later. And even well-meaning efforts can miss the mark, simply because the people who face these barriers weren't involved in a decision-making process. When solutions are designed without their input, they rarely work in practice. A ramp might be too steep, a platform too small, or the so-called accessible door too heavy to open. All because nobody thought to ask the wheelchair user what they actually needed. And if a building does get the official label of accessible, this still doesn't mean it's as easy to navigate as it is for everyone else. You'll probably get through the front door of your hotel just fine, only for you to discover that the space between your bed and the wall is too narrow for your wheelchair to fit in between. Or perhaps you'd like to go for a drink in the restaurant, only for you to discover it's just a few steps up. This gap between policy and daily reality is exactly what we're trying to address. Because as long as taking part in everyday life depends on extra planning, checking, or hoping things work out, you're not truly free to take part. And that's where our exoskeleton comes in. The exoskeleton isn't here to replace the wheelchair. A wheelchair is incredibly useful. It's fast, efficient, and freeing in its own way. But it also comes with limitations, especially in environments not built for it. You cannot stand up to see over a crowd. You cannot join your friends on a raised terrace or reach the top shelves in stores. And perhaps, most telling of all, you're looking up at people during conversations. And that's where we add value. Not by replacing what works, but by reaching what's still out of reach. The EXO enables someone to stand in a room full of people, eye to eye, to move through spaces that were never designed with sitting in mind. It gives back those special moments. Moments like joining your child on the playground instead of sitting by. Moments like walking next to your friends. Moments like standing at a concert. Our pilot said it best. It's about turning the small moments I now have to watch from the sidelines into ones I can be part of once again. Normally, today would be one of those changed moments. The moment where Dan walks in the exoskeleton, live, right here on stage. But today, we are doing things a little differently. As we've mentioned before, due to a medical issue, Dan won't be able to walk in the exoskeleton today. But that he won't be walking today does not mean it's not possible. We've seen firsthand what hard work, perseverance, and belief can lead up to. Up until the last few weeks, Dan was walking, training, and accomplishing things we could only imagine a year ago. Today, we'd like to take you through that journey of progress, through a short video and through the exoskeleton itself. We hope we can show you that we're not solving every barrier, but we are shifting what's possible. If we can make this kind of freedom possible for one person, we can also start to rethink what we expect from the system around us, so that access becomes a standard, not something you have to ask for.
Dus zeg maar op het moment dat ik er eindelijk in kan gaan lopen in een exoskelet wanneer alles samenkomt. En dan kan ik erin en kan gaan staan, en kan gaan lopen. Dus ja, dat is eigenlijk een beetje waar je het hele jaar naartoe leeft. En het zijn twee hectische maanden, drukke maanden. Dus ja, daar kijk je zeker naar uit. Het is altijd een positieve sfeer. Er zit een hele stijgende, progressieve leercurve zit er altijd in. In het begin gaat het altijd een beetje schokkerig. En op een gegeven moment zie je, al die opstart-errors die zijn eruit. Het is nu aanzetten, kalibreren, zitten, staan. En dan ga je lopen en dan ga je dat lopen trainen. En dan begin je eerst met 3 stappen, 6 stappen, 12 of 36. Je ziet steeds zo'n stijgende lijn erin komen. Nou, waar ik echt naar uitkeek was ook nog het testen van die NPC. Dus dat echt gemotoriseerd, gebalanceerd staan. Dat hebben we nu nog niet echt kunnen doen. Het was echt tot de motoren een bepaalde spanning hadden, waardoor ik met het exo gebalanceerd kon staan. Maar dat het exo zichzelf corrigeerde en dat ik erin stond, dat heb ik nog niet kunnen ervaren. En dat was wel iets waar ik echt naar uitkeek. Afgelopen week hebben wij dinsdag, vrijdag en zaterdag getraind. Mijn voet was een beetje blauw geworden. En daar hebben we foto's laten maken. En het blijkt dus dat er 3 breuken in mijn voet zitten. Zogenoemde marsfracturen, ook wel stressfractuurtjes. En dat komt door overbelasting. We denken dat het komt door het lopen in het exoskelet. Maar omdat ik niks voel, weet ik ook niet wanneer het pijnmoment ontstaan is. De breuk of breuken. Ja, je ziet de nareactie komen, de zwelling. Maar het exacte moment is heel lastig aan te wijzen. Omdat ik geen pijnreactie krijg. Ja, daardoor mag ik nu mijn voet niet belasten. Je mag er niet op staan, je mag er niet mee lopen. De enige manier voor mij om te staan is natuurlijk in een exoskelet. Ik moet zo'n 4 weken rust houden. Dit zou betekenen dat ik na de review pas ergens eventueel weer in een exoskelet zou kunnen lopen. Dat doet wel iets met je. Het is natuurlijk het nieuws wat je echt niet wil brengen. Om aan iedereen die een jaar lang werkt aan een exoskelet te moeten vertellen dat ik als piloot niet meer in het exoskelet kan lopen. Het is alleen voor mij op mijn maat gemaakt, dus je kunt ook niet iemand anders het laten vervangen. En dat ook nog 3 weken voor de review. Ik hoop dat er een leermoment uit te trekken valt samen met onze medische partner. En dat we dan gewoon weer verder kunnen op een veilige manier. Normaal, als je in een exoskelet staat, dan heb je altijd nog je krukken nodig waar je je balans kan houden. Ja, nu niet. Ik kon ze wegleggen. Ik kon gewoon blijven staan. Ik kon ook een beetje onbalans creëren. En er was nog best wel wat gewicht wat daarvoor nodig was. Wilde je die onbalans in het exoskelet met mij erin creëren. Dus ik was wel benieuwd waar dat naartoe ging eigenlijk. Ja, basketbal, we hebben een balletje overgegooid. We proberen te dribbelen. Ja, je moet om het exo heen een beetje een balletje proberen te stuiteren. Terwijl er ook nog een looprek voor je staat voor de veiligheid en mensen natuurlijk. Onwerkelijk, want ik heb het al 7 jaar natuurlijk al niet meer gedaan. En je ziet ook iedereen om je heen genieten van alles wat er gebeurt. En je geniet zelf ook.
Kira and Karel have taken you through the challenges and exoskeleton faces during a concert and the solutions we've developed to overcome them. Now, it's time to put theory into practice. Right here, right now. After months of building the exoskeleton and weeks of intense training, we're proud to give you a live demonstration. While the demo team sets up for this demonstration, we'll take you behind the scenes of all the preparations needed for a training session. We start every training with what we call an air gate. This means the exoskeleton is placed on its stand and will be moved in the air. It allows us to check whether everything moves and functions as it should, without the interference of ground forces. From this point on, we kindly ask you to remain silent so that the team can focus fully. Enjoy. As you can see, the exoskeleton actively shifts weight using the linear joints in the hip, just like our hip joints do when walking. Now that everything is moving smoothly in an air gate, we move on to a ground gate. For this, the exoskeleton is carefully taken off the stand in sitting position and will be placed on the bench. We will now take you through a typical route at a concert venue. From this point on, the exoskeleton will be supported from behind by our coach Hanna. Diagonally in front, you'll see our two safety catchers, Nienke and Shark. If anything unexpected happens, they're ready to step in. To maneuver quickly in crowded places, our exo can pivot. Stepping up and down is essential when dealing with level differences, like platforms or stages at a concert venue. To avoid obstacles, our exo can also walk sideways.
Step right, 3, 2, 1. Walk, 3, 2, 1.
Normally while walking, the pilot shifts his weight by pushing off his crutches. In our EXO, much of this effort is taken over, as it is the first Project Mars exoskeleton to actively distribute weight, using the linear joints in the hip and the coupled linears in the ankle. The remaining support needed tonight for walking is provided by our coach, Hannah.
Pivot left, 3, 2, 1. Walk, 3, 2, 1.
Now that we've finally found the perfect spot for the show, there's still one big challenge for our EXO: getting pushes from the crowd. We will now show you how our exoskeleton remains balanced despite these disturbances. Wow, what an incredible moment, right? As you just saw, using the exoskeleton takes an enormous amount of focus and energy. And that focus and energy wasn't just needed tonight. It was needed for every single training session leading up to this point, from the team and especially from our pilot. So now, I would like to say a few words to you, Dan, on behalf of the entire team. Because having you as our pilot and as part of the team has been truly amazing. Even after becoming a dad for the first time in August, you still made time for training sessions, meetings, and everything in between. Throughout this year, with all its highs and lows, you kept the spirit alive and the team motivated. So thank you, Dan, for your commitment, your energy, and your trust in us. And thank you for continuing your role as pilot next year with Project March 11. We couldn't wish for a better person to carry this project forward. But carrying this project forward is something we don't do alone. We're incredibly grateful to all our partners, whether you support us to funding, components, or consultancy. Your contributions are essential, and we simply couldn't do this without you. There's one person in particular that I want to thank tonight. Someone who has dedicated more time to Project March than any of us. Henny Rijke, our physiotherapist, has been with us since the very first team. And after 10 years of invaluable advice, he will now conclude his time at Project March. Henny, thank you for a decade of expertise, support, and enthusiasm. I would also like to extend a heartfelt thank you to all former March members. You stood by us during the tough moments, and you were there to celebrate the milestones. Thank you for always being there. And to our beloved family and friends, thank you for your endless patience, encouragement, and for keeping us grounded when things got stressful. Finally, I want to take a moment to thank my incredible team. From August until tonight, you've worked with unmatched dedication and heart. Each and every one of you deserves a massive round of applause because we truly couldn't have done this without you. So, with great pride, I welcome to the stage the team of Project March 10. The software department. The software department with Karel, Casper, Rens, Milou, Haaien, Rames, Mattei en Max. The mechanical department with Anneloes, Tom, Tjark, Kira, Meerte, Nienke en Hanna. The Electrical department with Stijn, Valentijn, Raymond en Thomas. The operations department with Siobhan, Martijn, Roos en Marieke. Woo! The management department with Cindy, Luca and Kirsten.
Gaan we een buiging doen?
Ja, 3, 2, 1. And our 28th and most important team member, Daan. I would like to invite all of you for a drink in the foyer. Thank you all for coming to our exoskeleton reveal.